Today we're going to talk about the last method of factoring, which is sum and difference of cubes. So I'm going to start off by making a list of my perfect cubes, or my numbers raised to the third power. So 1 to the third power is 1, 2 to the third power is 8, 3 to the third power is 27, 4 to the third power is 64, and then I'm going to use my calculator to make a list of the rest. I like to make this list just so I can recognize what my perfect cubes are. I made my list up to 12. You probably won't use this list all the way up to 12, but it's good to write them down and practice them. That way, when you see these numbers, you recognize them as perfect cubes. There are two rules that we're going to use for factoring these. One for the sum of cubes, so the sum of two perfect cubes, and one for the difference of cubes. They both look very similar, but they're just going to have different signs. Notice that both of these formulas, or both of these rules, have one minus sign in them, and the rest are positives. I have a fun way to remember these and to memorize them. The easiest way to understand these are with examples. So we're going to look at this 27x cubed minus 125y cubed. Both of these are perfect cubes, and it is a difference because of that minus sign in the middle. So I'll be using the rule for the difference of cubes. If I'm trying to figure out if 27 is a perfect cube, or to figure out the cube root of that, I can pop that into my calculator. So I can do 27 to the 1/3 power. If you don't know what those rational exponents means, look up a video on rational exponents. That means the cube root of 27, which is 3, and then 125 to the 1/3 power means the cube root of 125, which is 5. So that a here is the cube root of whatever my first term is. So here that would be 3x. The b is the cube root of that second term, which would be 5y here. So now that we have our a and our b, we're going to kind of forget about what we were given, and we're just going to focus on this a and b here. Earlier, I had said to notice that you only have one minus sign in these, so I like to put my plus signs and minus signs in first. In the rule, the first term that goes into this second set of parentheses is the a squared. So 3x times 3x is 9x squared. The last term is going to be the b squared. So 5y times 5y is 25y squared. The term in the middle is going to be a times b. So 3x times 5y, ignoring the signs there. So 15xy. I like to remember this formula with a little sing-songy action. So I'm going to put all of those letters up above these to remind me of their order. A, B, A squared. A, B, B squared. One more time. A, B, A squared. A, B, B squared. So you will have to memorize those rules, but the order of the A, B, A squared, A, B, B squared is the same in both a sum and a difference of cubes. We know that this is a sum of cubes. 64 and 1 are both perfect cubes. We know that this is a sum because it has a plus sign in the middle. So first I'm going to draw my sets of parentheses, and I'm going to put my signs in there. I like to remember those signs like soap, same, opposite, always positive. For the first term, I'm taking the cube root of the first term that I'm given, which would be 4, because 4 to the third power is 64. And here, y to the second to the third power would give me y to the sixth, because 3 of those together, exponent laws, you can do 2 plus 2 plus 2, which is 6. From here, I'll look at my second term. The cube root of 1 is just 1. So 1 is a perfect cube, it's a perfect square, it's a perfect everything. So remember, we're going to just forget about that first half and only look at this a and b. So I'm going to square the a, multiply the a and b together without the signs, and I'm going to square the b at the end. So 4 to the second power is 16, but let's talk about this y squared squared. When I square y squared, I can multiply those exponents together. Or I could think of this as y squared times y squared, which would be 4 y's multiplied together. B squared here is just 1 squared, which is 1. A times B would be 4y squared times 1, which is just 4y squared. And we have this factored. So let's go ahead and try this one on our own. Remember that you always want to look for a GCF before you start factoring anything. So after you write this down, look for a GCF first because neither one of these are perfect cubes. Also, remember my rule. If it starts with a negative, factor it out. Go ahead and pause the video here. Try these two. Come back when you're done. So you should have factored out a GCF out of both of these first. So I showed what that looks like. So now we're setting up both of those rules for a difference and then for a sum of cubes. So look how I put my plus signs and minus signs in there first. Then I'm taking the cube root of each term. And the first one I am squaring. 2x squared is 4x squared. Then I'm squaring the last term. 5 squared is 25. And then I'm multiplying those two terms together. 2x times 5 is 10x. For the second one, when I square x, it's just x squared. When I square 6, I get 36. And when I multiply those two terms together, I get 6x. Remember that those plus signs and minus signs are stuck in there, so they don't affect when we are multiplying a times b. You should always check to see if those trinomials are going to factor, but they do not if you do 25 times 4x squared. So if you try to split the middle term, you're going to get 100x squared. Here, there are no factors of 100x squared that add up to positive 10x. The same thing is going to happen with positive 36 in number 4. There are no factors of 36 that add up to negative 6, as you can see here. All right, so you know you're done when you can't factor anymore. Remember that you can always check your answer by multiplying those factors back together, and you should end up with what you started with. Have a great day. See you next time.